Dear students, today we will learn master theorem from the subject analysis of algorithm. Master theorem, it is one of the many methods that are available to calculate the time complexities of an algorithm. We are calculating the time complexities of an algorithm to get the best optimal logic the problems can have. Then time Master's theorems are applied on the recurrence functions only. In that recurrence function, if the functions are of type dividing or decreasing, then only we can apply master theorem on it. If the given recurrence function is not the type of dividing or decreasing, then we can't apply master theorem on it. So now we will learn first the master theorem. This is the standard function we can compare with the given recurrence. This is the given recurrence for relation T of n is equals to A T n by B plus f of n. Here n by b gives us it is one of the dividing function. So we can calculate here, we can apply here master theorem. So A means what? Number of sub problems. Then B is what? Number. N is what? Size of the problem. N upon B indicates the size of the sub problem, and f of n is the cost of the work done outside the recurrence. Then we can compare the given f of n function with the standard form nk log p. So here k is greater than or equals to 0, p is equals to real number, and for the value a is equals to greater than or equals to 1 and b is greater than 1. So now there are some cases we can study while applying the master theorem. We have to consider these three cases. We have to compare A-B relationship. Here, if A is greater than or equals greater than B of B raised to K, then we can directly write our function as n log BA, where log BA we can write it as log A upon log B. Now, for while considering case 2, there are three possibilities again. We will compare here parameter p. If p is greater than minus 1, then we can write the function t of n is equals to n log ba log p plus 1 n. Then suppose our function is matches the condition case 2 and it also follows p is equals to minus 1, then we can write the function in terms of n log ba log of log n. Now third condition is also mentioned here. Now case 3, we are comparing again here factor a less than b of k. If this condition matches, we will consider two consideration here, p greater than or equals to 0, p less than 0. If we match this nk log pn, and the second condition if we satisfy, then we can write t of n is equals to nk. Now we will solve one example on it. For that solving, I have written one example here. T of n is equals to 8t n by t plus n square. So now comparing this equation with our standard function t of n, at n by b plus f of n, we will raise equals to 8. Value of
we will see our next example which is based on master theorem. We will check why when we receive this we will check whether it is of type dividing or decreasing. Here we are getting n upon 4, that means this is in the form of dividing relation. So we can solve this example using master theorem. So while we will compare this with our standard function t of n is equals to a t n upon b plus f of n. So while after comparing we receive a's value is equals to c, b is equals to 4 and f of n is also n square upon log square n. are having values of f of n is equals to nk log p, nk log p is equals to n square upon log square n. After comparing with this, we get here value of k is equals to t and value of p is equals to 0. We know that value of p is the real number. So here we received value of k is equals to 0. Now we will check for our case a b raised to k. But what is the value of a here? 16. What is the value of b? 4. And value of k is equals to 2. So it gives us 16 and 4 square is also 60. So we received a is equals to b raised to k. So then now we are satisfying our case to a is equals to bk. Now before applying this, we also have to consider these three cases. P greater than -1. Value of p is equals to 0. So 0 is greater than -1. So we are satisfying our case number 2 first condition. So we will write here as T of n. T of n is equals to n log b a log p plus 1n. So now after comparing with this equation n log ba, we can write it as, now here log, what is the value of b here? N, value of b is 4, value of a is 16. So we can write n log 4 square. So we received here n square. So now we have solved this example and the time complexity we received here using master theorem is equals to n square. This is how we are solving dividing function with the help of master theorem. Dear student, first we have seen master theorem for dividing function. As we know, master theorem we can apply on both type of relations, that is dividing relation and decreasing relation. We have already seen the dividing relation, how we can solve with the help of master theorem. Now we will see decreasing function. For that function we are having same standard function as T of n is equals to a t n minus b instead of n upon b. Here for decreasing function we are having n minus b plus f of n. The value of a should be greater than or equals to 1, b greater than 1. N is the size of problem, a is equals to number of sub-problems, and n minus b means size of the sub-problem, and f of n is equals to nk. In previous dividing function it was nk log p, but here it is f of n is equals to nk. Now we will see cases to solve the master theorem. Master theorem will apply in these three cases. Value of a is the main parameter, a is equals to 1, then we can write the given function in the form of big O of n k plus 1. If a is greater than 1, then T of n is equals to big O of a n upon b into nk. And next, if a is less than 1, then we can write T of n is equals to big O of nk. Now we will solve an example on it. For that I have written here T of n is equals to T n minus 1 plus n square. Now here condition is decreasing, means we will check for these three cases. Now with comparing with our standard function a t n minus b plus f of n gives us value of a is equals to 1. Here nothing is there, so we can write, we can consider here value of a is equals to 1, value of b is equals to 1, and f of n is equals to n p. Value of f of n, value of value of f of n is equals to nk, and value of f of n given as n square. So we received here value of k is equals to 2. Now we will check with our parameter a is equals to 1. We will solve this a is equals to 1. Here case 1 is satisfied. So now we can write T of n is equals to b n o of n k plus 1. So what is the value of k here? Value of k is 2. 2 plus 1 it is 3. So this is how we can solve our master theorem for decreasing function. I hope you have understood all the all the methods, that is dividing and decreasing function, how we can solve this with the help of master theorem. Thank you.